welcome to an Algebra 1 second semester review video. Now, every Algebra 1 class can be a little bit different, but there's a good chance that some, if not all of these topics you've covered this semester, this spring semester, and so if that's the case, then hopefully you'll enjoy watching this review to help you study for your final exam. So we're going to start here with rules of exponents. And so the thing we have to remember is that when we're multiplying two things together, our regular numbers will multiply. So 3 times 4 in this case, those multiply together. And then when it comes to x's, we add their exponents together. Because this is saying that I have x 4 times. And this is saying I have x 2 times. And so if we want to combine those, now we've got 6 of them, and so we'd write x to the 6th. So the normal numbers 3 and 4 get multiplied, but the exponents get added together. On number 2 and 3, we have another part to this, that we have a variable to the 0 power. Anything to the 0 power is 1. And so if it's in the problem with other stuff, you can really just cross it out and say that it's 1. Or even just cross it out and ignore it completely. I can think of this like it's just a 2, and 2 times m cubed is 2m cubed. As you're watching this video, you should make use of the pause button and the speed controls to either speed up or slow down until you find the right speed to listen to it on. For some, I may be going too slow. For others, I may be going too fast. So use those speed controls. Also, in general, for every odd problem, an even problem is similar, but not exactly the same. So you might think about pausing after I do the odd problem and then trying the even one yourself and then playing again so that you can see if you did it right. It is a long review, so it is a long video, so keep that in mind as you're going through. So on number 3, we've got v to the 0, which I can cross out and think of this just as 4. So 4 times 3v squared, I'm going to do the 4 times the 3 and get 12. And the v squared doesn't have anything now to interact with, so it stays v squared. We also could have said, well, v to the 0 and v squared, I'm going to add those exponents, and 0 plus 2 is 2. And that would be another way of thinking of how to combine our v's there. The other thing that we want to do on these problems is, if you look up at those instructions, they say your answer should contain only positive exponents. So that's a part of this whole process. I'm going to do 3 times 2, because those are normal numbers. And then I have 2 options here. If I want to do p squared and p to the negative 1, I can either add their exponents, or I can move this down to the bottom to make it positive, and then think about how these would cancel, whichever one is easier for you. If we just add our exponents, we'll get 1, so this should be 6p to the first power. And of course, we don't have to write the first power because we know that if no power is written, that it would be to the first power. On this section, so the first section is actually focusing on a rule where we are multiplying things, so we add our exponents. Here we have a power to a power. And so we have to remember, first off, that everything in here gets that power. So I'm going to have to figure out what 2 to the 4th power is, as well as figuring out what m to the 4th power is. And then the other thing about that is these exponents, they don't add together, they multiply. Because when you're saying m to the 4th, you're saying I have m to the 4th 4 times, like this. And so, well, how many m's do I have? 4, 8, 12, 16. Oh, well, that's the same as doing 4 times 4. So we need to rewrite m to the 4th as m to the 16th. We need to find 2 to the 4th. And so that means that we need to do 2 times 2 times 2 times 2, which is the same as 4 times 4, which is actually also 16. Interesting. Now, same thing is going to happen on 6 and 8. 7's a little bit different. So you could pause the video, see if you can do this now yourself, and then play it to see if you were right. So here we want to do 3 to the 4th power, and we want to multiply these exponents together to get v to the 8th. So let's figure out what is 3 times 3 times 3 times 3. So that would be 9 times 9, which is 81. So 81 v to the 8th. On 7, so I left that out whenever I said that was talking about the rest of these being similar, because remember, anything to the 0 power is 1. So you can either think of this as everything I have to 0 is 1. So my answer is 1. You can think of it like, well, I'd get 3 to the 0, and then I'd do 4 times 0. And so both of these are 1, and so together they make 1. But no matter what, when we see that 0 power, we should think that somehow things are going to cancel. If I thought, oh, well, I'm going to mark that out, anytime you mark out everything, there has to still be a 1. Even if you're doing a problem like 2 over 2, that's not a 2, 2 over 2, when you mark that out and say they cancel, it doesn't equal 0, it equals 1. So same idea here, that because we can just get rid of it, it's not actually 0, it's a 1. So on 8, we want to do 4 to the 3rd, and we want to do p to the 4th to the 3rd, and so we multiply those exponents together. And so I just need to figure out what 4 times 4 times 4 is. So that's 16 times 4, which is 64. So 64 p to the 12th. So the difference, if you're looking between these problems and the first problems, what's an easy way to tell when you multiply and when you add? Here, there were no parentheses, and here there were. So the fact that I have parentheses, that otherwise my powers would be right next to each other, they're just separated by a parentheses, that tells us to multiply, whereas here, they're not right next to each other, we don't have parentheses, so we know we need to add. Changing the game again, this is the quotient rules because we are dividing. And so when you see division, you should think subtraction, or you should think somehow about canceling out. So I am going to treat the normal numbers, these 2's, like I would if it was just 2 over 2, that those cancel and equal 1. So these cancel and just give me a 1 on top and a 1 on bottom that I probably won't end up needing. Maybe I'll need them. And then if I'm doing x squared over x to the 4th, I can subtract my exponents. If I do 2 minus 4, I get a negative 2. And then we have to remember, oh, I don't want positive exponents. And so to get rid of I do want positive exponents. I don't want negative exponents. Sorry. So to get rid of this negative exponent, I move the whole thing down to the bottom. I moved the x down to the bottom, which is the only thing we have. And so that gives me 1 over x squared. The other way to do it is to say 4 minus 2 and then know that you need to put it on bottom because we have more on bottom. Because essentially what we're doing is we've got 2 x's on top and we've got 4 x's on bottom, and so we would cancel 2 of them out. Where are these 2 x's left? Are they left on the top or the bottom? They're left on the bottom. The top doesn't have anything left, so it has to have a 1 to show that we have a fraction. On 10, there's nothing for 2 to interact with, so 2 is going to stay on the top. V over v squared, we can subtract our exponents, or we can, we can just think about canceling, but somehow we should end up with v being on bottom. So either 1 minus 2, which is negative 1, so 2v to negative 1. If you think of it this way, it's important to realize that only the v moves down to the bottom. The 2 has its own exponent here of positive 1 that we just don't have written down. So the v to negative 1 moves down to the bottom and becomes v to the positive 1. So our answer is 2 over v. We've done 10 problems. Give yourself a pat on the back. If it seems like I'm talking really fast or going really fast, keep in mind I'm trying to make this video as quickly as possible to get it out. So like I said, it does not hurt to use the video controls. If I'm going too fast, slow it down. If you're like not fast enough, challenge accepted, then by all means speed it up. But only if you can actually still learn from it, if that's your goal here. All right, let's get back to this. 11, 2 over 4 is going to cancel. Just like a regular 2 over 4 without ends, we say they have a 2 in common that I can cancel and get 1/2. Then our ends, this would be like an n to the first on the bottom, so I do 4 minus 1 and get 3. That n cubed goes on the top because there are more n's on top right now. There's 4 of them on top, 1 of them on bottom, so 1 is canceling out. So I'd have a 1 n cubed on top and just a 2, I got distracted, just a 2 on bottom, or you don't actually need that 1 in front, so it'd just be n cubed over 2, like so. Number 12. So anytime you see a 0 power, you want to mark that out because, and it's the letter and the power, not just the power, because now I can ignore that, and that actually makes this problem easier and quicker. We have 2/4 again, so that's 1/2. The m cubed is still going to be on top, and now only the 2 is on bottom, because this is going to be 1, this is going to be 2. You can leave it as 1 m cubed, but it's better to write it as just regular m cubed. And so that's our answer. Switching gears, we want to look at scientific notation, and this does also end up having exponents. So scientific notation, if we remember, is where we are trying to write it as a number between 1 and 10, and then we have a times 10 to some power. And so our goal is to get the decimal from here to here by moving it by powers of 10. So we would have to move it 1, 2, 3 times. And so my exponent is going to be a 3. Now, it could be a positive 3 or a negative 3, depending on which way we move it. And I think for me, the easiest way to remember it is to say 2700 is a relatively big number. And so a relatively big number is going to have a positive exponent, because what we're trying to do is say 2.7 times 100, 10 with 3 zeros. If 2.7 times 1000, that's 2700, not 2.7 times if I made it a decimal because I had a negative exponent. A negative exponent would be talking about a fraction, or in other words, a decimal. So this is our answer. So if that was a little confusing, the other side to this then is I want to move this so that I have one number to the left of the decimal, so I have to move it over 2 places to get it right here. So that this is 8 times 10. But 0.08, the original number, that's a small number. And so I'm going to make this a negative 2, not a positive 2. And whenever I'm thinking about this and trying to decide if I have a big number or a small number, I try to think about whether or not some amount of money that I would be happy to be gifted with. So I would really like someone to give me $2,700. That's a big number. On $14.08, I would actually probably be a little bit annoyed if somebody walked up and handed me 8 cents just randomly. Maybe not. Maybe that would be nice, but not anywhere near as nice as $2,700. So it's kind of a flawed logic, but I think that can kind of help. It certainly helps with even smaller decimals, like 15. Would you really want somebody to hand you, this would be like 3/1000ths of a cent? No, that would be ridiculous. Like, no one's going to hand you that amount of money. So we know that our exponent here is going to be negative. We want it to come all the way over and be to the right of the 3, so that this is a number between 1 and 10, which 3 is a number between 1 and 10. So 1, 2, 3, 4, 5. I had to move 5 places, so that's 10 to the negative 5. On the other side of that, 500,000 would be a great amount of money to be gifted. Hint, hint, wink, wink. So I'm going to try to get it right here between the 5 and the 0. I'm going to move it 1, 2, 3, 4, 5 to make it happen. So 5 times 10 to the positive 5th power. Now we can use that same logic of big numbers versus small numbers whenever we're going the other direction. These are written in scientific notation, and we want to change them to standard form. And so if it's a positive exponent, I want to move it the direction that makes it bigger than what it is right now. So if I want 1.9 to be bigger by 1 decimal place, I'm going to move it this direction so that I get 19. Another way of thinking of it is to say 1.9 times 1 with however many zeros is this exponent. So this would be like saying 1.9 times 10. Well, 1.9 times 10 is 19. This is also positive, so we want to move this the direction that makes it bigger, which is to the right. 1, 2, 3, 4, 5. And we're going to put zeros each of these places where we don't have a number. So this is going to be 800,000. On 19 and 20, we've got negative exponents, so we're going to make them smaller, which means moving to the left. If I move to the right, I'm going to make 3.8 bigger, like 38 or 380. But I want to move to the left 4 places. One of those places is here to get past the 3, and then 2, 3, 4. So I'm not actually adding 4 zeros, I'm adding 3 zeros, and that can be something that trips us up if we're not careful. And finally on this section, 20, we're going to move to the left 1 to make this a smaller number. And again, maybe you'd like to have somebody give you 67 cents. I personally would rather have $67 than 67 cents. I would consider this to still be a pretty small number. So that's the scientific notation. Now we're going to jump into solving equations by square roots. So the important thing to think about, this is from a chapter that's all about quadratic equations. A quadratic equation is any equation that has a variable squared. And so the most important thing for you to remember about that is that 95-ish% of the time we should get 2 answers for a quadratic equation. So it might be that you look at 21 and can think, oh, well, if I do 10 squared, I get 100, so m must equal 10. And you would be right. But it's important to remember it can't just be 10 because almost all of these equations also have another answer. And so you have to think about what else when I square it equals 100. And the answer to that is -10. If I do -10 times -10, which is the definition of squaring, I get positive 100. Now the instructions here say solve by taking square roots. The idea is I square root this side and I square root this side, and that means m equals positive and negative 10. So that's another way of writing it. You can write it out as a list, or you can write it together with a plus and minus. And that's how we do that. We have to, though, remember that in the process of us solving an equation, if we take a square root, we're going to need to put a plus and minus sign to make there be 2 answers. So on 22, we're going to do the same thing, although this one might seem a little trickier because what squared equals 38? Well, the square root of 38. Actually, if you square it, equals 38. Not just the positive square root of 38, but also negative square root of 38. So even when it doesn't necessarily make a ton of sense, this 38 here, we still are going to think about what the square root is. And since we don't know the square root of 38, and this doesn't actually simplify either, which we'll get to in a second, we would just leave that as our answer. 23, we actually have a step we need to do before we square root because x squared is not currently by itself. But if we subtract the 1, which if we do it to one side, we have to do it to the other. If we subtract the 1 over and then we square root, then we'll get our answer, which is positive and negative 8. Square root of 64 is 8. And 24, this is a -5 times k squared, so we're going to do the opposite of times. We're going to divide. So k squared equals 11. And so I don't know the square root of 11. You probably don't know the square root of 11. Your teacher probably doesn't want the decimal, but would prefer that you just leave it as the square root of 11. 11 is prime, so it can't be simplified at all. So that is our answer. On this next section, we are simplifying square roots. So the thing that you want to remember about simplifying square roots is that we're looking for a factor pair where one of the numbers is something that we can square root. So when I think about 28, I can do 1 times 28, which that technically is a perfect square. We're looking for things other than 1. 1 doesn't actually help us. 1 times 28, 2 times 14, 4 times 7. We're looking for, out of these options, do any of them have a perfect square? Perfect square means a number that you can find the square root of. So 4 and 7 work. We can say that the square root of 28 is the square root of 4 times the square root of 7. And then we can say, well, I know that the square root of 4 is 2, and I don't know the square root of 7, so I leave it as square root of 7. The other way to do it that your teacher might have taught you is to make a factor tree. And so that means you split it up into 4 and 7, and you split the 4 into 2 and 2. And what you do is anytime you have a pair of numbers, you write one of them on the outside because you're essentially saying this pair of 2's, the square root of that is just 1, 2. And then whatever doesn't have a pair goes on the inside, only looking at the bottom of the tree at the prime numbers. So this 4 doesn't affect it at all. We just look at the bottom. Depending on what number they give you, I would say is how I would decide which of the two methods to use. If you really easily come up with this factor pair, then this is a great way to do it. If you have problems coming up with a factor pair, then try it the other way. 26, 54. So we know 1 and 54, but that's not going to help. And we, at farther along in the review, are going to be doing factor pairs like this. So that's part of the reason why I'm doing all of this. 3 and 18. Not 4, not 5. How about 6 and 9? 9 is a perfect square. So we're going to split this into square root of 6 and square root of 9. And the square root of 9 is 3. Square root of 6 you can't do anything with. 6 is 2 times 3, so there's also not any perfect squares inside of 6. So our answer is 3 square roots of 6. Now 27 and 28 we are multiplying. So in order for us to do this, we have to know that numbers that are outside of our square root can interact and numbers inside can interact, but they can't like cross over. So I can do negative 4 times 5 and I can get negative 20. And I can do 8 times 6 and get 48, but still underneath my square root. And then I need to check to see if I can if I can simplify 48 by looking for perfect squares. Or this one actually might be a good one to try doing the factor tree on. I could do 4 and 12, which is 2 and 2, 4 and 3, 2 and 2. If I have here's a pair and here's a pair, those both mean that I need 2 2's on the outside. I have a 3 left over to stay inside. And so the square root of 48, when I simplify it, is 4 square roots of 3. Don't forget about this negative 20 in front. That's going to multiply together because they're right next to each other right here. So we're talking about multiplication. Negative 20 times 4 is negative 80 square roots of 3. So that would be my best answer here, my simplest answer. Same thing on 28, although I think the number is a little bit easier that we get here. 5 times, well, it'd be like there's a 1, or we could just say that it's 5 because it doesn't have anything to multiply with. And then 5 times 10 is 50. If you've not already tried, maybe pause the video here to see if you can come up with the square root of 50 simplified without my help. Alright, I'm going to assume that you either didn't want to pause or are back. So 50, we're going to split into 25 and 2. Because I know the square root of 25 is 5, and I know that the square root of 2 is the square root of 2. So then I just need to times this 5 and this 5 together and get 25 square roots of 2. All right, we're going to start looking at graphing type problems for quadratic functions. And so here we have the vertex of some quadratic functions. Now the thing that you need to know about this is our vertex formula, which is negative b over 2a. This formula gives us the x value of our vertex, but our vertex is a point. It's the highest or lowest point in our function, and so that means that means that we're going to have to plug it back in to also find our y value. So we start by saying what a, b, and c are, and then now we can plug it in. This would be negative 12, because negative b over 2 times a, so 2 times 2, that's negative 12 over 4, which is negative 3. That's the x value, so our answer is going to be negative 3 comma something. Now I need to plug the negative 3 in where the x's are in my original equation. And so I'm going to do negative 3 squared, which is positive 9, times 2 is 18. 12 times negative 3 is negative 36. Then I'm going to add 17 to that. Now, if I do 18 minus 36, I get negative 18, and negative 18 plus 17 is negative 1. So that is my y value. The answer to this is the point negative 3 comma negative 1. All right, 30. So we want to label a, b, and c. And all three of these are actually going to seem pretty similar, although there is a special order of operations thing to make sure you're aware of here. This is like a -1 x squared, so a is -1, b is -4, c is -8. So that's negative b, which is also -4. So a double negative makes it positive. And then we're going to do 2 times a, so 2 times -1, which is -2. 4 divided by -2 is -2. And now we're going to plug this in where our x's are. Now, it's important to notice how I'm plugging in at the beginning of this, because we have a negative, and then we're plugging in -2 and then squaring it. And order of operations say that exponents come before multiplication. So this negative in front is like we're multiplying by a -1. And so we need to square first and get 4, and then times by -1 and get -4. And that's a really easy thing to mess up. So I would suggest if you're doing this and you get a weird number that you don't think is right, that you just try instead to change this sign right here, because most likely that's where the issue is going to be. Not always, but a lot of times. Then we're going to do -4 times -2 and get +8. And then we want to put these together. Those go away, and we just get -4. So our x value is -2, our y value is -4. But make sure you're paying special attention. We want to square, which does get rid of the negative, but it had a negative in front, so that makes it negative again. Another way of thinking of this is -2 squared is like having -2 times -2, right? So how many negatives do I have right now? I have 3. An odd number of negatives makes your answer negative. Again, these are all going to be similar, and so you might think about pausing so that you can do it for yourself. So b is 2, so -2 over 2a, so 2 times 1, so -2 over 2, which is -1. We're going to plug in -1 squared plus 2 times -1 plus 2, so that's 1 minus 2 plus 2. So that ends up just being 1. So our answer is -1, 1. And A, B, C. So negative b over 2 times a, which is -1. Oh, this works out really similarly, except we've got -2 over -2, which is +1. So -1 squared plus 2 times 1 minus 5. Now, this is the same kind of thing as 30, where we've got to pay attention here. I had like half of a class come up and say, isn't -1 squared +1? And yes, -1 squared is +1, but there are no parentheses here. We're plugging in 1. If there are parentheses, it's just around the 1. And so what they're asking us to do is to square 1 and then to make it negative. So -1 plus 2 minus 5. So these together make 1 minus 5, which is -4. So my answer is 1, -4. Okay, so these are kind of tiny, but I wanted to be able to see all of them. I guess I could have rearranged it, but hey, too late now. These are multiple choice. So if you don't have multiple choice, if you're graphing it yourself, you would do this a little bit differently than how I'm going to show it because it's multiple choice. So keep that in mind, that if it's not multiple choice, you're going to make a table of values using the vertex as a center point and going out to either side. What we want to do, since we are trying to do the least amount of work as possible, is we want to start off looking at what A is. So in this case, A is -2. If A is positive, your parabola opens up like a U. If A is negative, it opens down like an N. So if this is a -2, it opens down, so that means it's not A, it's not B, it's either C or D. Now if I notice, the vertex, which is the top point of each of these, is not in the same place on these. And so that means all I have to do is find the vertex, even just the x value. I don't even have to find the x and y, just find the x. And then that should tell me which one it is, either C or D. So I'm going to do -b over 2a, just like on the last problem. That's +8 over -4, which is -2. So let's see, this x value is at -2, this one is not, so it's not D, it has to be C. So if we were having to graph the whole thing, just in case that's what you are required to do, you'd put the -2 in the middle here and you'd pick points on either side and you'd plug in all of these points into your x's up here so that you can graph a whole bunch of points. All right, so here we want to look at A first. So this is just a negative, so in other words, a -1. Since it's negative, that means it also opens down, so it can't be A, can't be B, might be C, can't be D. Well, what do you know? We just did it with very little thought. Had no work whatsoever. We know that it's C. Same type of problem here. There is also another trick that you can use that I'll point out, and it doesn't work on every one of them, but later on in the review we will be looking at some factoring. If you can factor this, so what multiplies to get 12 and adds to get 8, which is 2 and 6, and then solve, that x is -2 and x is -6, then our answer choice that we would look for is where is my parabola going through -2 and -6 on the x-axis. So not here, that's -3 and -5. Not here, it's not going through at all. Not here, it's not going through at all. Here, -2 and -6. So this is our answer. You don't have to do it that way. You can do it the way we did 34 and 33, but that's another option if for whatever reason the first two things we talked about, deciding whether it opens up and down and finding the x value of the vertex, if those aren't working out very well for you, that's an option. If it factors, you can try that. Not all of them factor though, like 36 doesn't factor. There's nothing that multiplies to get 4, that adds to get -2. Although that actually suggests to us, no, it actually doesn't help us out at all because none of these go through even points. So if any of these went through like a normal set of points, like -2, -4 or something, we'd know it couldn't be that because we know we can't factor. But I'm getting a little carried away here. So A is a +1, so it can't be A and it can't be C. If we do -B over 2A, we get +2 over 2, which is 1. Let's see, that's over on this side. Nope, that's not where that one is. Yes, that is where this one is. This has an x value at 1, so our answer is D. Switching gears, we're going to solve these equations with the quadratic formula. Now, it's possible that your teacher could give you problems in this section that you actually could solve a different way, like by factoring, but make sure that if they ask you to use the quadratic formula, that you actually do the quadratic formula. Now, these will not factor because I purposely made them that way. We want to say what A, B, and C are. We want to remember what the quadratic formula is. If you haven't heard it before, there's a nice song for it. It's to the tune of Pop Goes the Weasel. It goes x equals -b plus or minus square root b squared minus 4ac all over 2a. And I meant to mention this before. If you're watching this video and it's not making much sense, well, you probably didn't make it to 37 anyway, but this is intended to be a review. If you're trying to learn all this for the first time, you probably want to find some other videos. And in fact, I have a whole lot of videos from this semester if you go to somewhere else in my channel to look for them, that they can actually, they're with the intention of actually learning it and not just reviewing it. So just shameful video plug there. We want to do this formula. We want to plug A, B, and C in. So to start off, I'm going to do -b, which is also negative. So -5 plus and minus square root of b squared minus 4 times a, which is 7, times c, which is -3, all over 2 times a. Now there's 3 things we're going to do kind of on the same step. If we're comfortable with it, we're going to say -5 is +5. That should be pretty easy. And we're going to do 2 times 7 on bottom, which is 14. And then on the inside of this, we are going to do -5 squared is 25. And 4 times 7 times 3, well, if you do 4 times 3, you get 12. 12 times 7 is 84. and the two negatives here make a positive, so that's plus 84. 25 plus 84 is 109. So we're going to rewrite that, or we maybe could have done that on the same step and not had to write the step in between. So our only question at this point is, does square root of 109 simplify? So we do a quick run through of numbers up to like 10-ish to see if any of them, and if any numbers divide in, and we find they don't. 7 honestly was our likeliest candidate, and it doesn't divide in. So this would be our answer right here. All right, now you might try pausing the video to see if you've got the hang of this, but 39 is a little bit different, so make sure that you come back for 39 unless you think you know what the added step is. So we've got A, B, and C. So we're going to do x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we want to do 9 plus 4 times 3 times 2, which is 24. 9 plus 24 is a 33. And 2 times 3 is 6. Now, a lot of people will try to simplify the negative 3 and the 6, but it doesn't work like that. And so later on in the review, or if you are in an Algebra 1 class and you've done this, you might have done this most recently if you're going in the same order that we did. Pretty recently in class, we did problems like this where he said, you know, simplify, or we had to try to simplify. Maybe we got this because we added 2 fractions together. And so the question is, does this simplify? And the answer is no, because in order to simplify this, everything would have to divide by 3, including this x, which does not divide by 3. This is the same thing that's happening here. We have addition on the top, and so we would have to be able to divide all 3 of these things by 3. And because it's a square root of 33, I can't divide it by 3. If it was just regular 33, that would be fine. But the square root of 33, you can't divide by a regular 3 and get square root of 11, because one's inside and one's outside. So this is actually my answer, just like that. On 39 and 40, the added step is to move the number from the right side over before you start. We want this to be ax squared plus bx plus c equals 0. So the fact that it doesn't equal 0 means using the quadratic formula right away will give me an incorrect answer. So now I can label a, b, and c and plug in. I guess this is n equals instead of x equals. It doesn't really make much difference. So we're going to do the same sort of steps we've been doing. Negative 1 is positive 1. And then we can do the 2 times 3 on the bottom and get 6. Inside here we want to do a positive 1, because negative 1 squared is positive 1. And we want to do negative 4 times 3 times negative 6, which gives you positive 72, not 2, positive 72. So 1 plus 72 is 73. Let's check, and I didn't actually say this on the last one, but we need to check the square root. The square root of 73 does not simplify because 73 is a prime number. 33 back here didn't simplify because all we can do is 3 times 11, and neither of those are perfect squares. So this is our answer. We want to do the same starting step on 48. We're adding 2 because it's negative instead of subtracting 2. So we're going to do 3. If it helps you to write your b's as capital letters so they don't look like 6's, or you could just change them to x's instead. We're going to do b equals negative 2 plus and minus square root of b squared minus 4ac all over 2a. So negative 2 plus or minus the square root, we've got 4 plus 24, which is 28. And then we're over 6. Now 28 can simplify. In fact, I feel like we did that earlier. This is 4 and 7, and you can square root 4. So our next step is to write this as 4 square roots of 7. And then now we look at this and we say, oh, I can divide all of these by 2. I can divide the negative 2 by 2 and get negative 1. I can divide the 4 square roots of 7 by 2, and it divides the 4. So I have 2 square roots of 7. And I can divide the 6 by 2 and get 3. And so that would be my answer. And if you're asking, do I have to do that? Well, we always want our simplest answer. So I would say yes. Yes, you do. 41 through 44, find the discriminant of each quadratic equation, then state the number and type of solutions. And it even tells you what it means, 2 real, 1 real, or no real solutions. So the discriminant is just the part underneath the square root in the quadratic formula, b squared minus 4ac. So we're going to do the same process. I feel like we've been doing this for ages now on this review. We want to do the same process of a, b, and c, but we only want to do the part under the square root, not even including the square root. You don't have to do the square root at all. So this is 64 minus 8 times 8, which is also 64. The discriminant of this is 0. And so one of the things with this, you have to remember that if you get a positive number, you have 2 real solutions. If you get a negative number, you have no real solutions. And if you get 0, you have 1 real solution. And that's because if I do think about the square root in the quadratic formula, then the square root of 0 is 0. That means the plus and minus isn't actually going to be doing anything. You're going to add 0 and subtract 0, which is going to give you the same answer twice. So that's why there's only 1 real solution when our discriminant is 0. A 42. A, B, C, B squared minus 4A, C. So let's see, 36. 3 negatives make a negative. 4 times 9 times 6 is something that I don't know off the top of my head. 36 times 6. Actually, I do know that. That's 216. I am not feeling super confident about that. So give me a sec. Nope, I was right. 216. That's why you should always feel confident. No, you shouldn't always feel confident, but I should have felt more confident than I was. That's negative 180. And we want to say, oh, that's 2 real solutions. The way the instructions are worded implies that you do actually need to find the number. Like, it would be pretty easy to say, well, I don't know what 36 minus 216 is, but I know that it's negative, and I wrote the wrong thing. There's no real solutions when it's negative. I apologize. Because we can't square root a negative number and get a real number. So what I was saying before I interrupted myself is you can know that this is a negative number without finding what it is and then come up with the answer. But if it says find the discriminant, it wants you to actually find the number. So I would recommend that you be safe rather than sorry and go ahead and write the number and the other part of the answer. All right, A, B, and C. B squared minus 4AC. So 100. This is a minus because there's 3 negatives. 4 times 5 is 20. 20 times 5 is 100. So 100 minus 100 is 0 again, which means 1 real solution. So I bet you can guess what we'll get on this last one. Now this actually has some trickiness because there's no, what is C if I don't have a number here? Well, that means C is 0 if you don't have one. If we didn't have an X term, then B would be 0. If we didn't have an A term, this wouldn't be quadratic, so that wouldn't work. We want to do B squared minus 4AC. So this is 16. 4 times 10 is 40, times 0 is 0, so plus 0. Well, that's still 16 as our answer, or half of our answer. And then since it's positive, we would square root 16 and get 2 answers because we know the square root of 16, or we know we can find it. 2 real solutions is the other part of our answer. All right, shifting gears slightly, this starts the chapter that we had on polynomials. So adding, subtracting, multiplying, and factoring, and some solving by factoring was what was in this chapter. So here we start with adding and subtracting. You want to start off by looking at what's in the middle. It's telling us to subtract the things from the first parentheses with the second one. So like we're going to do 3 minus if there's any regular number here, which there's not. So 3 minus nothing is still 3. It also tells us to write our answer in standard form, and 3 should come last in standard form. Now let's think negative 3x to the 4th minus 2x to the 4th. So minus 2x to the 4th. That makes negative 5x to the 4th. And then there's nothing else actually in this parentheses, but we do still need to think about minusing negative 7x cubed. So that would change it to a plus 7x cubed. So this would be my answer, because none of these now are like terms, because x to the 4th and x cubed are different and are different from a regular number. Now, 46 has us adding. So we always want to check in between our parentheses, because it's really easy to look at these and decide, oh, I need to FOIL, but that's multiplication. That's coming up at 49, I want to say. Maybe later, like 50. So we want to do 4v cubed plus 4v cubed. And I choose to add those together because those are both v cubed. So it's like saying 4 apples plus 4 apples is 8 apples. And so we're saying there that v cubes are apples. Negative 7, negative 4 can also be added together, and they would make negative 11. We didn't have to change any signs because it was plus in the middle. Minus in the middle means change the signs in the second one. So here, on 47, it may be a better way to do it is to write the second parentheses under the first strategically, like write the 7r to the 4th under the 3r to the 4th. Whoops. Write the 8r cubed underneath this r cubed. Write the negative 8r squared under this r squared. And then when we add them, we want to put it in standard form. So the r to the 4ths are going to come first. And then the r cubes are going to come next. And then the r squareds, and then the number, which doesn't have anything to actually add with. For subtracting, we could do the same thing, but make sure you change the signs. This is the biggest mistake, and it happens so much. And all you have to do is remember, a negative makes all these change signs, so that we have negative v plus 7v cubed and minus 6. So when I write this out, I have negative 3v cubed plus 7v cubed, which is 4v cubed. Then I have v squared. So 4v squared doesn't have anything to add with in the second parentheses. I have negative 7v minus v is negative 8v. And negative 2 minus 6 is negative 8. So that's my answer. Here we move on to multiplication. When we multiply with polynomials, we either use the distributive property, or if it's a binomial times a binomial, meaning 2 terms by 2 terms, then we can use a more specific pattern called FOIL. So here where we've got 5 times this trinomial, we're going to use the distributive property, which means we're going to do 5 times 3n squared, which is 15n squared, and then 5 times negative 3n, which is negative 15n. Notice it, since I don't have an n out here, I just have 5. It just changes the numbers. It doesn't change the n's at all. And then 5 times 1, which is 5. And that's all we have to do, because we are finding the product. Next, on 50, we want to distribute 3x squared. This time we do have an x involved, and so that will change our x's. So 3 times 6 is 18, and x squared times x squared is x to the 4th. And then 3x squared times x, there's no numbers to multiply, so it stays 3. X squared times x becomes x cubed. 3x squared times 6 is 18x squared. And then this is our answer. On 51 and 52, this is an example of a binomial times a binomial, so we can use FOIL. Now you can use the distributive property as well. Just know that you have to distribute the 5x and the -3. So a lot of people like this acronym FOIL to help them remember what they need to do. It stands for first, outer, inner, last. So we're going to do either way we do it. Even if we use the distributive property, it will look the exact same. We're going to do first, which is 5x times 6x, which is 30, and x times x is x squared. So this is the thing that really can trip people up. If we're multiplying, it does change x times x to x squared. If we were adding, that's where it wouldn't change it. It would still be x. So we are multiplying x times x and getting x squared. Now, outer is 5x times 5. It's the two outermost terms. 5x times 5 is 25x. Inner is -3 times 6x, which is -18x. And the last one of each parentheses, -3 and 5, is -15. Every time we do this, we want to put the middle terms together, so that anytime we have like terms, we add them together, just as a rule, to make this as simple as possible. 25x minus 18x is 7x. And so that would be our answer. On 52, same thing. 3x times x, which is 3x squared. 3x times 2, which is 6x. 1 times x, which is 1x or just x. 1 times 2, which is 2. Add the middle terms. 6 plus 1 is 7. So that's 6x plus 1x is 7x. So here is our answer. On 53 and 54, there's like a special pattern that you can do for this to help you remember what it gets, or you can just rewrite the parentheses and then use FOIL or the distributive property like we did on 51 and 52. I recommend this, where you just rewrite it a second time and then FOIL. Notice that that means our answer is not 64n squared plus 25, although it's really close to being that. If we just square each of these and we don't actually multiply it out, we won't have thought about what the middle term should be. So 8n times 8n does give us 64n squared. 8n times 5 gives us 40n. And then 5 times 8n gives us 40n again. And then 5 times 5 gives us 25. So foiling is just how we figure out the middle term should be 80n. Same thing on 54. So 4x times 4x is 16x squared. 4x times -2 is -8x. And then we're also going to do that with the -2. -2 times 4x is -8x. And -2 times -2 is +4. The middle terms add together. They're the same sign, so they don't cancel out. They come together to make -16x. And so this is our answer. 55 and 56, same type of problem, but now we've got a binomial times a trinomial. So FOIL does not work. It does not have enough letters. So we need to think about the distributive property. 2k times 2k squared is 4k cubed. 2k times -k is -2k squared. 2k times 5 is 10k. Then we want to do the same thing with the -7. -7 times 2k squared, I can write it here, or I can write it underneath the other k squared that I have, so that I can see what my like terms are. -7 times -k is +7k. And then -7 times 5 is -35. We want to put the k squareds together here and the k's together here. so that we get negative 16k squared and 17k. But the 4k cubed and the negative 35 don't change because they don't have like terms to add with. Here we want to do 7x times 4x squared, which is 28x cubed. This is going to be pretty similar to what we did on 55. 7x times 6, except for bigger numbers. That's an x, obviously, not a half k, half x sort of situation. 5 times 4x squared is 20x squared. 5 times 7x is 35x. And 5 times 6 is 30. So add my like terms. Add my like terms, so that's 77. Not x squared, don't put that squared there. When you add x's together, they're still x's. So that's my answer, without that smudge preferably. What do we have next? We've multiplied. Now we are going to, it's kind of like dividing, because we're going to factor, and there are kind of two general strategies for factoring. One is just looking for what's in common so that you can divide it out of everything. The other is where we split into two parentheses. So the 57 through 60 here is the first one, that they all have a common factor that I can divide by. So I want to figure out what that is. Like here, it would be a 4 that I can divide by. And what I want to do is I want to write down what I'm dividing by on the outside of a set of parentheses. And on the inside, I want to write down what's left if I divide them all by 4. We've now factored out the common factor from that expression. Now, you could also have chosen to take out a negative 4 instead of a positive 4. And what that does is it changes all of the signs because we'd be dividing by a negative. I personally am like, whichever of these you want to write is fine. I don't have a preference unless they're all negative. And if they are all negative, then yes, you need to take out the negative. But on all of these where there's, well, 58 and 59 as well, there's a mixture of negatives and positives. You could do it either way. On 58, we can divide all of these by 9, but also we could divide them all by m to the 5th. I can't pick something bigger than 5 because this last one, if I divide by something bigger than m to the 5th, I'm going to end up with m's on bottom, which I don't want to do. If I pick something smaller than 5, they'll all still have an m in common, so I would have to go back and divide again. So what we're doing here is we're just saying what happens, that's an m. What happens when I divide these all by 9m to the 5th? I get 10m to the 4th minus 3m squared plus 10 without an m because those m's cancel. And this would be our answer. And on 59, same thing. I want to divide them all by 5, or we could choose to divide them all by negative 5 if we want. But make sure, biggest thing I would say here is make sure whatever you're dividing by, you write outside. Because our answer, if we're supposed to have something that when you multiply it together, you get what you originally had. And without having this 5 out here, that won't be the case. 5 divided by 5 is 1, so you can write 1 in or just in. And this is another one where, really 58 as well, you could take out a negative. You could put negative 9m to the 5th. But usually you see it done most often when the first one is negative, that people will go ahead and take out the negative more so than just if a random middle thing is negative. Just so you know. But if they're all negative, then take out the negatives. So 60, they don't have any numbers in common because n to the 4th doesn't have a number, but they do have an n in common that we can divide by. So that's n cubed plus 9n plus 7. And that would be our answer. So that's the first kind of factoring. We have another kind of factoring where we try to split into two parentheses. Here we want to think about what multiplies to get 2, a positive 2, that adds to get negative 3. And inside of our parentheses, we're going to split the r squared up into r and r. This is the opposite of FOILing, by the way. So we're splitting the r squared up into r and r, because r times r is r squared. We're going to split the 2 up, and that's what's going to be here and here. But we have to pick things so that if we were to add them together, we'd get our middle term, because that's what happens when we do outer and inner. So all that to say, I just wanted to get rid of these things right here. All that to say, well, let's think about what multiplies to get 2 that would add to get negative 3. And at first you might be thinking, how do you make a negative 3? Well, 1 times 2 is 2, and so is negative 1 times negative 2. If I add negative 1 and negative 2 together, I get negative 3. Now, if this is your semester review, you will have also probably done problems where you solve for r. That is only something you need to do to write r equals if you have equals 0 here, or if it says solve. Well, it should really do both. It should have an equals 0 and it should ask you to solve. But that's why I'm not going any further with this, is because I don't even have an equation, so it doesn't make any sense to try to say what r equals. So we're going to do the same thing in each of the rest of these. So we're going to say what multiplies to get negative 21 and adds to get 4. I find it helpful at times to make a list of all the things, including 1 in itself, that multiply to get 21. I usually do that with positives and then add in my negative later. For instance, I need one of them to be negative if I'm multiplying to get negative 21. And so 3 and 7 should work, because 7 minus 3 is a positive 4. So I want n plus 7 and n minus 3. Now on both of those, when we split up the r squared and the n squared, it just split into r and r and n and n. But if I have a number in front, it makes it harder, because we have to think about splitting this up into a k and a 2k, and which spot do we put the k and which spot do we put the 2k, and it makes it more complicated. There is a way that you could guess and check by splitting up the 2k squared into k and 2k, and it wouldn't matter how you started that, but then splitting the 10 up and trying to find the right combo to split it up so that you've got two things here that when you do this and this together, you add to get 9. But the other way to do it, where you are not having to guess and check, is for you to use something like the box method or slide and divide. I have taught both of these methods in the past, and there's actually a third method called split the middle term that's quite popular, but I'm going to go ahead and do the box method. And so the start of the box method is to draw a box. And that box needs to have 4 spaces. It's actually like we're doing a Punnett square from science class. We're doing a reverse Punnett square. We're going to fill in the inside with what we have and then get the outside. So we want to put 2k squared here, and we want to put the 10 here. In the other 2 spots, we're going to have to say, we're first going to have to say 2 times 10 is 20, and then we're going to ask ourselves, what multiplies to get 20 that adds to get 9? So similar to what we did in 61 and 62, but just a little bit different here, that we want to think about. What do we want to think about? Oh, we have to think 2 times 10 and get 20. We can't just say what multiplies to get 10 that adds to get 9. And most of the time that won't work out anyway. You would have to think about 2 times 10. So 20 is 1 times 20, and 2 times 10, and 4 times 5. So that's a start. And we want to then pick which pair adds to get 9, which is 4 and 5. When we put it in our square in the diagonal here, we put k's with it, because we're adding to get 9k. So we need 4k and 5k. Now, we're reverse Punnett squaring this with some factoring involved. We want to look at these top 2 and say, what do these have in common, like what we did on 60 in previous problems. So they both have a 2 and a k in common. We're going to look at 5k and 10 and say they have a 5 in common. We want to look at the top and bottom, the left side. We want to look at these two, 2k squared and 5k, and say they have a k in common but not a number. 4k and 10 has a 2 in common. And then we're going to put plus signs here and here, and the top and the left side show us what our 2 parentheses are. So k plus 2 and 2k plus 5. And that would be our answer. We're going to do the same thing on 64. So 3 times negative 8 is negative 24. We'll want to think about in a second what multiplies to get negative 24. That adds to get 2. Where did my box go? I guess I'll just complete the square. That's a math joke that you might or might not get. So we put the 3m squared in the top left and the negative 8 in the bottom right. We say what multiplies to get negative 24, that adds to get 2. What we want to do is 6 and negative 4. So 6m and negative 4m. So I want to look at the top two here and say, what do they have in common? I want to look at the bottom two and say, what do they have in common? And make sure you notice they have a negative in common as well as a 4. And I want to look at the left side and say they just have an m, and then here they have a 2. To check yourself, by the way, 3m times n, and this is like a Punnett square, 3m times m should give you 3m squared, 3m times 2 should give you 6m, and that should work for all of them. So our parentheses are m plus 2 and 3m minus 4. By the way, it doesn't matter which order you put the parentheses in, as long as you keep the 3m minus 4, it has to be 3m minus 4. Whether you put it first or second doesn't matter, but it has to be 3m minus 4. And m plus 2 has to be m plus 2. It just doesn't matter which order you put it in. Now, I didn't mention this when we did 63 and 64 because I knew what was supposed to happen, but we do want to always check and see if what we start with has something in common. So on 65, for instance, all of these can be divided by 2. That was horrible. Let's try that again. All of these can be divided by 2. And so we're going to do that to start. I'm going to say 2 times k squared minus 14k plus 45, just like we did earlier, where we were taking out the common factor. But I want to now check, because of what I have inside, a k squared, a k, and a number, I want to check to see if this will factor into 2 parentheses as well. And it probably will. And so what multiplies to get 45 and adds to get negative 14? So 1 and 45, 2 doesn't divide, 3 does, 4 doesn't divide, 5 does, and that's it. So 5 and 9, if I could add those together, would get 14, so I need to make them both negative, k minus 5 and k minus 9. And that 2 just hung out in the front because we divided by 2 at the beginning. 66 is going to work really similarly. So I'm going to say they all have a 3 in common. I'm going to make sure to write down that 3. It's not a good idea to try to do these 2 steps at the same time, or you might confuse yourself. Maybe you can do it, but I would recommend writing out separate steps. What multiplies to get 10 and adds to get 11? 2 and 5 doesn't work. It's got to be 1 and 10, which is a pair that we can often forget. Now these last 2 look a little tricky, but actually in a way are the easiest ones we have, because there's not a middle term. That would mean that we could say there's a plus 0 in. Like, I could actually rewrite this and say in the middle is plus 0 in. And that means that I need to find what multiplies to get negative 9 that adds to get 0. So this throws people off because they think, well, 9 and 0 or something like that. Well, no, we want to add to get 0. We want to say what multiplies to get negative 9. So our choices are 1 and 9 and 3 and 3. We want to basically subtract them to get 0, so we have to use 3 and 3. So one of them needs to be positive, one of them needs to be negative, and this is actually a special pattern as well, that if there's only 2 terms and you can square root both of them, then you're always going to end up with 2 parentheses that are almost the exact same. They just have different signs. So same thing is true here. The square root of 64 is 8, and so this should be x plus 8 and x minus 8. Now that only works if they're subtracting in the middle, not if they're adding in the middle. If we said x squared plus 64, you can't actually factor that at all. There's no way to get those signs to work out the way you want them to. Now here we're going to solve by factoring. And so what we want to do is get everything on one side if it's not already, so that we have an equals 0. Notice when you look at 69 and 70, which say equals 0, that if you tilt your head to the left about 90 degrees, that equals 0 looks like a surprised smiley face. That's what we want. We want it to have a surprise smiley face in order for us to factor and then finish solving. So it's like we're doing the same thing that we just did, but we're going to add a step, maybe at the beginning, but for sure at the end. Since this already equals 0, I'm ready for my parentheses. So I'm going to say what multiplies to get negative 14, that adds to get negative 5. I only have two choices. It's got to be 2 and 7. Since I want it to add to get negative 5, it has to be negative 7. Now at this point, we want to know what a equals. So a minus 7 could equal 0, or a plus 2 could equal 0. And that would give us an answer of 0 over here. And so that means that I want to basically separate these into two different equations where they equal 0, or have a surprised face. And then I want to solve. So here I would add 7 and get 7. Here I would subtract 2, and I would get 2. Negative 2, I mean. So my two answers are 7 and negative 2. By the way, you can solve that with the quadratic formula and get the same answers, but compare that work and see which you prefer. Also, you can solve it by quadratic formula, but this asks us to solve by factoring. So if we did it with the quadratic formula, we may or may not get all of the points that we were allowed. So let's do it again. Let's say what multiplies to get 56 and adds to get 15. I'm going to pause to give you a chance to think about it. All right, 7 and 8. One of the problems with this, and if you actually have me in class, you've heard me say this a ton of times, unless you don't listen to what I say, which is a possibility. It can be so hard on these factoring problems to think of the right pair of numbers because our brain will hook onto the first thing we think of, and it'll make it really, really hard to think of the other one. So that's why you'll see me make a strategic list. I always start with 1 times the number, even when it's like I know that it can't be that, because usually it's pretty obvious if it's not going to be that. And then I count up. So I go next to 2 and I say 2 times what gives me 56, because 2 is pretty easy to divide into things. I start there. So that's 2 and 28. And then I say, okay, does 3 go into it? Which 3 has this cool property where if you add the digits of 56, 5 plus 6 is 11, if that's divisible by 3, our number is divisible by 3. So since 11 is not divisible by 3, then 56 is not divisible by 3. Then I check 4. Well, we can either check 4 by trying to divide it in, or check this out. If 28 is divisible by 2, then because we already divided by 2, then we know that 56 has to be divisible by 2. This may not make a lot of sense. You might be like, okay, you lost me, and please stop doing this. So you divide 4 in and get 14. And then 5 doesn't go in. 6 doesn't go in because 3 didn't go in. 7 goes in, and 7 and 8 is what we want. So that's kind of the process that I go through whenever I'm stuck trying to find factor pairs, is that sort of list making thing. All right, 71. Now, I don't have a surprised face here on the right side, so I better go ahead and add the 8 over to the left. It doesn't actually have anything to add with, and so I just want to write it at the end. And then I can check to see, do they all have something I can divide by, which they don't. So I get to use the box method, or slide and divide, or split the middle term, whatever it is that you know how to do in order to factor this. So 7 times 8 is 56. Hey, we just made a list for 56. And you know what adds to get negative 57? Negative 1 and negative 56. How neat is that? Now, when using the box method, anytime both of your diagonals are negative, it's going to make both of these negative. And that's something, it's like my biggest complaint about the box method is that it's not super obvious that you need to do that necessarily. But we want to take out the negative from both of those and say that that makes them both subtraction. All right, top. 7x squared and negative 1x squared has an x in common. 56 and 8 have an 8 in common. 7x squared and 56x have a 7x in common. And then there's nothing in common here. And so we would say 1. And again, we made them both negative. And this is where checking our Punnett square can help. X times -1 is what gives us -1x. Somewhere I had to have a negative there. And so it makes sense to put it here. Now our parentheses are x minus 8 and 7x minus 1. And so this whole thing we just did was just to rewrite this into 2 parentheses that equals 0. Now we want to split this up into 2 equations. X minus 8 equals 0 and 7x minus 1 equals 0. And then we want to solve these. So we're going to add 8 to both sides on the first one and get x equals 8. On the second one, we're going to add 1 and then divide by 7. And so that means x equals 1/7. So there's our 2 answers. And here we go. We need to get our surprise face by adding 2 to both sides. So 2n squared plus 15n plus 18 equals 0. They don't all three have something in common that we can divide by. There is a number in front of n squared, so we have to use the box or slide and divide or split the middle term. Whatever your preference. And we want to say what multiplies to get 2 times 18, which is 36. That adds to get 15. We had to do that one earlier, I think, too. Well, 4 and 9 don't work. What are my other options? 3 and 12 works. So again, I almost got caught in that trap I was warning you about, where the first thing I thought of, 4 and 9, it's really hard to come up with the factor pair that works. And I've even already worked this once, so I already got the right answer one other time. This is tricky. 12 and 18, make sure you pick the biggest thing they have in common, which is 6, and not just 2 or just 3. Here we're going to have 2n, and here we're going to have 3. So we've got 2n plus 3 and n plus 6 equals 0. Let's set them both equal to 0. Whoops on that. For some reason I keep trying to write n's and m's as the opposite. So annoying. I should just use x's all the time. And so you subtract the 3 over, divide by 2, that gives us -3/2. And then for the other, you just subtract 6 and get -6. And that is solving by factoring.
All right, here we have solving each proportion. Be sure to check for extraneous solutions. So we are going to cross multiply on each of these problems to solve, and what we want to do at the end or at the beginning is check to see if there are any values that would make our denominators equal 0. And that happens when there's a variable in the denominator. So on 74, for instance, how I have n right here. Well, there is a number that when I plug it in right here would give me a 0 on the bottom of my fraction. And we're not allowed to divide by 0. That's not a thing we do. And so if we happen to solve and get that number, whatever it is, as an answer, we'd say, oh, well, that's not really supposed to be an answer. It's extraneous. So we're going to cross multiply. And here we have 6 times v minus 3, which we need to make sure that we distribute. If we're doing 6 times a binomial, we have to give that 6 to both things, which is an easy thing to forget. And then this ends up being just a linear equation to solve that hopefully we're pretty good at these days. So 8v minus 6v is 2v equals -18. We're going to divide both sides by 2 and get v equals -9. So what we want to do is, there's not a v in our denominators up here, so there isn't a value that if we plug in gives us 0 on bottom, which means -9 should be fine. I can't plug in -9 to the bottom of either of these fractions. So -9 is really a solution, not an extraneous solution. We're going to do that for each of these, and they should end up being pretty similar. So again, feel free to pause the video and work it out for yourself to see if you've got the hang of it. We're going to cross multiply here and here. So 2 times 2n plus 5 equals 11 times n, which is 11n. So we're going to distribute and get 4n plus 10 equals 11n. So what I'm trying to do at this point, by the way, is get my n's together on one side and my regular numbers on the other. And so you can subtract the 11n over to the left and get there, but it's faster to subtract the 4n over to the right, because then we already have the 10 on this side, and then now we have 7n, and we can divide and get 10/7. You will notice probably in Algebra 1 at least, like you've done problems with proportions like this before, but usually they work out to be pretty nice numbers before this, and you can even usually guess, like you can say, when I multiply 6 by to get 8, and then have the same thing be true on top. But these are purposefully more complicated in Algebra 1 so that it's not likely that you'll be able to do that, certainly not on every single one. And because of that, fractions are going to happen quite a bit as answers. So we're going to distribute this 12. So I'm going to subtract the 12k over to this side and get 60 equals negative 2k. Divide by negative 2. As you're working these out, you can get lots of types of equations after you cross multiply. So we happen to be getting linear equations for each of these, but it is possible, depending on what we have to multiply, that we could get a quadratic equation, which we would try to factor or use the quadratic formula on. That's the likeliest thing other than linear, is to have a quadratic. Probably wouldn't have some other strange equation to solve. And a lot of times they should factor versus you having to do the quadratic formula. It's always good to check. So x is negative 3. And I have not, on 74 through 76, I haven't been talking about extraneous solutions. So the idea here is if I put 10/7 where n is that going to give me 0? So 2 times 10/7 plus 5. I don't even really have to work this out. I just have to think it through. Like, does it make any sense that 2 times a positive number plus 5 would equal 0? And the answer to that should be no. The other way of going about it is to just say, well, what is the number that doesn't work? If I set this equal to 0 and solve, I subtract 5 and divide by 2 and get negative 5/2. So the only thing that actually wouldn't have worked for this is negative 5/2. We could call that an excluded value for this fraction. And so as long as we didn't get that as an answer, we're fine. Same thing here on 75, except there's 2 things we can't have. We couldn't plug in 0 here for this k, because that would give us a 0 on bottom. Here it's a negative 5 plus 5 would give us 0. So if we got 0 or negative 5, we would know that those are not really answers. And then on 76, it's a negative 2. That would give us a problem. And so I was close. Negative 3 is close to negative 2, but not close enough. That's not how it works. So that's cross-multiplying to solve proportions. Now we are simplifying expressions. And the big thing here is that if you have things where you're multiplying, so if I have 2b over 18b squared or something like that, I'm allowed to cancel the numbers, I'm allowed to cancel the letters, because all that's happening on top here is multiplication and on bottom is multiplication. So as soon as we see that we're doing b plus 2 instead of b times 2, the rules for simplifying are different, that we are looking for the same exact thing on top and bottom. I can't cancel out this b plus 2 unless somehow on the bottom I can also have a b plus 2. And so you might be thinking, well, that doesn't make any sense that we could somehow get a b plus 2 on bottom. But the bottom is something we can factor. We can say that the b squared splits into b and b. We can say what multiplies to get 18, that adds to get 11, which is 2 and 9. So b plus 2 and b plus 9. The whole point of this is that we are supposed to be able to simplify on the majority of them. And so we should see that there is a b plus 2 that I can cancel. If we pick the wrong pair, that won't happen. But that's a clue that you picked the right pair, is that you did get something that cancels out. Now, a common mistake is to think, oh, I'm just left with b plus 9, but that b plus 9 needs to be on the bottom of a fraction with 1 on top. And so it's 1 over b plus 9. On 78, so there's kind of two approaches you can take with this. You can always check to see at the beginning, can I divide everything by something that they have in common? So for instance here, I can divide by 4x, all of these. I can divide this by 4x, I can divide this by 4x, and I can divide this by 4x. And if that's the case, that I can divide everything by 4x, I don't need to write down 4x anywhere. We'll see on the next one, if we can't divide everything, we still will have to write down what's in common. But since everything has it, I can just say this is 9x over 7x plus 7. And then nothing else cancels. I could rewrite the bottom of this by taking out the 7 that they have in common. And I would say that either of these answers would be acceptable. Writing it with the 7 outside is supposed to help us see for sure that nothing else cancels. But since nothing else canceled, then we could just leave it the other way. On 79, we could check first and say, does everything divide by something? And the answer is no. And when that happens, we don't have v squared, so we can't split into two parentheses. But on top, we do have something in common just with these two. If it's only in common on top, we have to write down what they have in common, and then write down what happens if we divide them both by that. And so that's different than what happened on 78. It's the difference between, can I divide everything on top and bottom versus only being able to divide on top or bottom. So the difference between and or. So because we were able to do that, we have a v plus 9 in common that we can cancel, which leaves us with 4 over 1, which is just 4. And then 80 is similar to 77. We still want to kind of keep in the back of our mind that we should check, hey, can we divide everything by something? No. Can I divide on top? Can I divide on bottom? No. But I do have an r squared, so it is likely that I can split this into two parentheses on top. The bottom, there's not anything we can do to it because it's not squared and there's nothing in common. So we want to know what multiplies to get negative 28 that adds to get negative 3, which is negative 7 and positive 4. Again, it's a really good sign that we got r plus 4 twice. And so that leaves us with r minus 7 over 1, which we can just write as r minus 7. So when you get a 1 on top, you have to put that 1. When you get a 1 on the bottom, that 1 doesn't matter. And that's the difference between having 1/2 and 2 over 1. 1/2 isn't 1/2 unless there's a 1 on top. But 2 over 1 is 2, whether we put the 1 on bottom or not. This section says, state the excluded values for each. In other words, what numbers would make the denominator in each fraction equal 0? So this is asking us basically about that same idea of what gives us extraneous solutions or things like that. Like, what is it that I'm not allowed to plug in for x here because it would make me divide by 0? And the way to figure this out is to take the bottom of your fraction and set it equal to 0 and solve. It doesn't matter what the top is because the top of our fraction is allowed to be 0. It just matters where the bottom equals 0. So in this case, you might know it without actually having to solve it, that if I plug in 0, that's the only way to get 0. But if you would rather set it up and solve it, we should still divide by 45 and then get that x equals 0. And on each one of these, we should set the bottom equal to 0 and either think about solving or actually solve it. So for 82, where does 16 equal 0? Well, the answer is nowhere. So there are no excluded values on 82. All of our values work. You can plug in anything. 83 and 84, we're going to set the bottom equal to 0 and solve. And for 83, this is a quadratic equation, so we're hoping that we can put it into 2 parentheses. And what multiplies to get 8 and adds to get -9 would be -8 and -1. So n minus 8 equals 0, n minus 1 equals 0. That means I'd add 8 over, and I'd add 1 over. So my 2 excluded values here are 8 and 1. I'm going to do the same thing on 84. So I'm going to do 30k minus 36. I don't know why I rewrote it whenever I already had it there. I can add the 36 over and get 30k equals 36, and then divide both sides by 30. If you were thinking about factoring, you actually can totally factor as tried to make it easier, I guess, on yourself. Like I could take the 6 out that they have in common, and then I would have smaller numbers. I'm going to end up taking the 6 out here instead. I can divide them both by 6 and get 6/5. So 6/5 is the number that does not work for this problem. Now we're going to multiply and divide. So the important thing to remember here is that when you divide fractions, you flip the right one, not the wrong one. So I don't even have to worry about that on these first two. Either we can just multiply the numerators, multiply the denominators, and then simplify, or you can try canceling things out ahead of time. The rules for canceling are that you can only cancel something on top with something on bottom. It doesn't matter if you do it in the same fraction or diagonal like this, but I can't cancel the 6 and the 8 and say they have a 2 in common because they're both on bottom. It has to be top and bottom. If we just multiply on top and then multiply on bottom, then we're still going to have to simplify. 10 and 48, we can divide those both by 2. And then n squared and n cubed, well, there's one more n on bottom than there is on top. So we're going to end up with an n on the bottom. We can use the same skills that we used at the beginning of the review where we subtract exponents. It's really the same type of problem at that point when we start simplifying. Same sort of deal on 86. So I'll show you this way on this one, the idea of canceling beforehand. Like I can take this v and cancel it out with one of the 2 v's on bottom. It doesn't matter which one. I can take this 6 and turn it into a 3 and get rid of that 2. And then whenever I multiply across, I just have to make sure I don't leave anything out because of the marks I've made. So 9 times 3 is 27, and 1 times 5v is 5v, and that's my answer. On 87, I need to flip the second fraction. And really this should be kind of similar to what we did on the last problem, the last set of problems, not the excluded values, the one before that. Like we want to do the same sort of checking like that I have a b squared, so I'm going to try to split this into 2 parentheses. So b minus 2 and b plus 1. So this b minus 2 and this b minus 2. And so that leaves me with 1 times b plus 1 over 7b. And nothing else cancels. Those b's can't cancel because not everything has a b. 88, we're not going to flip. We're going to factor the top of the first one. So what multiplies to get 36, that adds to get 13, which is 4 and 9. And we can factor what's in common on bottom. Yes, it has an x squared, but since it doesn't have 3 terms, we can't split it up into 2 parentheses. We can just say, well, they both have an 8x in common, which when we divide gives us x minus 2. And and we can't do anything with the second fraction because there's not anything in common. There's not an x squared. So the only thing that actually cancels here are these x plus 4s, and so this is going to feel, I mean, I personally feel like this is not very satisfying as an answer. The x plus 9 times 1 is x plus 9. 8x times x minus 2 times 1 is 8x times x minus 2. You can multiply that back out if you want to, but I would suggest just leaving it, because then it looks like you at least check to see if it would simplify, which is what, as math teachers, we like to see. So that was multiplying and dividing. And we've got a couple more multiplying and dividing, and then we switch to addition and subtraction.
If you like this video, please hit the thumbs up, and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture, and I'll try to answer it. Thanks for watching!